Hello there, welcome back. This is another session that you're going to continue with the rules of indices, and we did look at the first two rules, the multiplication and the division, and this session I'm going to look at other three. Number 3 is for multiplication of indices of the powers. We have a scenario like this: a power m multiplied by n. So you have a number power, a certain power, and then you're multiplying by another indices. So in this case, we multiply the powers. You have a power m times n. So an example, just to demonstrate that, you have been told to solve for x in 3 power 2x power 3 is equals to 3 power 4 times 3 power 8. So in this case, we have various rules that we're going to use here. On my left hand side, I'm going to use the rule number 3, the multiplying of powers. So you get 3 power 2x power 3. So you multiply the power 2x times 3, get 6x is equals to 3 power 4 times 3 power 3. The bases are the same. We add the powers, 4 plus 8. That is the first rule. So this is going to be 3 power 6x is equals to 3 power 4 plus 8, 12. So the bases are the same. We drop the bases. We're left with 6x is equals to 12. And then my x is going to be, I divide on 6 on both sides. And then I get 12 divided by 6, which is equals to 2. So my x is equals to 2. That's how you can be able to apply that rule. Let's look at rule number 4. A power 0 is equals to 1. That is the rule number 4. Any number power 0 is equals to 1. So let's demonstrate this. You have a scenario where you have a number like this. Example, 3 squared divided by 3 squared. So using the second rule of indices, for the division, we subtract the power. So this is the same as 3 power 2 minus 2. You get 3 power 0. So doing this question using the other method, 3 squared, that is 9, divided by 9, that's going to give us 1. So you can be able to say that now this one here is the one that is represented as 3 power 0, meaning this is equals to 1. So any number power 0 is equals to 1. That is a low number 4. Look at the fifth rule. The negative index. So a or negative n, when we have the power being negative, this is the same as the reciprocal of that number. So this is the same as 1 over a power positive n. So that is the negative index. So whenever you have a power being negative, in this case, it's just like you are getting the inverse of that number. Otherwise, that number is going to be 1 over that number, but now the power is positive. That is the negative index. So whenever you have a scenario like that, you can be able to represent it like that. Also, it can be in another case where now when the power is when you have it like this, or 1 over, let's say another case here, b power minus m. So if it is already in the lower side of the denominator of a fraction part, to make this one positive, you find the reciprocal. So it's going to be on the other side. So it's going to be b power m. Now m is positive because of this minus. It means you get it like that. So generally, it can have that index when it is negative. You can just divide by 1 to make it positive. That one is, of course, the reciprocal. In other words, an example, you will have example 3. You will have us like 2 over 3 power negative 2. You have been told maybe to evaluate that. So this one is going to be what? This minus here, you can just find the reciprocal. So it's going to be 3 over 2. 2 over 3 reciprocal b. Now 3 go on the top and then 2 on the bottom. And then power 2, which is equals to 9 all over 4. So when it is that minus there, just means you are finding the reciprocal. You can have another example. Find the value of m in 1 over 27 power m times 81 power minus m power minus 1, sorry, is equals to 243. So whenever you have a question like that, the best thing is to look whether you can write it into a number of the same base. Like this case, you can see 27, 81, and 243 are all the, you can write them in the base of 3. So you can write it like this. 1 over 27 is 3 cubed power m times, to bracket, 81, that is 3 power 4 power minus 1 is equals to 243, that is 3 power 5. So when you write them like that, the first case here, this is to bring 3 power 3 on the upper side. This is 1 over that number. So it's like if I wanted to be on the top, I use the row number 5 there. I'm going to be having now 3. I change the sign of the power minus 3. Then power m times 3 power 4 times power minus 1 is equals to 3 power 5. Then I open the brackets. So I have 3 times power minus 3 get 3 power minus 3m times 3 power minus 4, because 4 times minus 1 is minus 4, is equals to 3 power 5. And then the bases are the same, so I use the first row, I add the powers. 3 power minus 3 m plus minus 4 is equals to 3 power 5. So then the bases are the same. I drop them. I now use the powers there. Minus 3m minus 4 plus minus is equals to 5. So minus 3m is equals to 5. I take minus 4 on the other side. I'm going to be having it's going to be plus 4. So minus 3m is equals to 9. M will be 9 divided by minus 3. Divide on both sides, I get minus 3. So in this case, my m is going to be minus 3. Let's do the last example in this part. Let's solve for x in the following. (27 out of 8 power x plus 7 is equals to 4 for 9 power minus 3x. So when you look at our question here, we have 27 over 8 and then 4 over 9. The first thing that should click into our mind is how can we make this number in terms of the index form. Now, 27, of course, that one is 3 power 3. 8 is 2 power 3. So you can write them like that. So this is 3 cubed for 27 over 2 cubed for 8 into bracket x plus 7 is equals to 4. That one is 2 squared all over 9, 3 squared power minus 3x. Then I can see this is 3 cubed, 2 cubed, meaning all of the 3 and the 2, they are cubed. So we can factor out that power. We have 3 over 2 power 3, then we multiply by x plus 7 is equals to, and this is 2 cubed, this is 3, 2 squared, this is 3 squared. Both of them are squared, so we can factor out that square. We have 2 over 3 square, then multiply by minus 3x. And then we can open the bracket. You have 3 over 2, then 3 times x, that is 3x, then 3 times 7 plus 21 is equals to 2 over 3 power minus 6x. 2 times minus 3 is minus 6x. Now, note that both sides, the right and left side of the equal sign, we have 3 over 2 power something. This is 2 over 3 power that. Our bases are not the same. This is 3 over 2. This is 2 over 3. How do we go about making them the same? We are going to be, look at this sign here. This is power minus 6x. And look at our fifth law of indices. When it is minus, it is meaning, we get the reciprocal. So we can use this one. We change this sign to be positive so that we change the fraction part. So we are going to have 3 over 2 power 3x plus 21 is equals to, now when we change the sign, it's going to be the reciprocal of 2 over 3, which is 3 over 2 power now positive 6x. Not unless you change on this side, you can also change on this side, but you change everything to be minus. But this one is the one that is a bit simple because it's just direct. Now our bases are the same, 3 over 2, 3 over 2. We can drop them and then you'll be left with the power, that is 3x plus 21 is equals to 6x. Then you can put the right hand together. I have now 21 is equals to 6x plus 3, and closing the equal sign is going to be minus 3x. So 21 is equals to 3x. Then divide by 3 on both sides, you will be left with x is equals to 7. That's how you solve for that kind of a question. Guys, thank you very much for watching.